Alright, so how about some exercises for those conjugate theorems? These exercises we're working backwards. We already have the zeros working backwards to try to get that polynomial function. So I gave you 3 practice problems. First one, very simple. Second one, still pretty alright, still pretty simple. Third one, it's still simple. These are simple. I hope you think so too. So go ahead and pause it. And turn each one of those things into a polynomial. Now look at the instructions, right? Polynomial function of least degree, and that means you're not adding in any extra zeros, and has a leading coefficient of 1. Okay, so in other words, once you get done with the factors and you go ahead and expand all that out, and then you're pretty much done. I'm going to go ahead and cut you a break on that third one there. You don't have to expand it out. Just leave it in factored form. Might save you about 20 minutes. Okay? Alright. Pause. And you're back. So let's look at the first one. First one, essentially, if you're just given integers, it's very easy to put them all into the parentheses and just change the signs of each one of those zeros. So as the factors. So x plus 1 times x minus 2 times x minus 4. And then I just expanded it all out and got my function f of x equals x cubed minus 5x squared plus 2x plus 8. That one was pretty easy. It was so easy, in fact, I have decided to extend this just a little bit. What if we change it, and instead of this having a leading coefficient of 1, let me cross that out. Let's say it has the exact same zeros, but this time goes through the point 1, 3. So here I'm going to have myself an a value in there that's not necessarily 1. So I should have the function f of x is equal to, let's throw an a up front, and let's write it in that factored form. It's going to be easier for us to figure out what that a value is. So it's x plus 1 from the first factor, x minus 2 from the second one, and x minus 4 for the third one. Now, with that additional point, plug 1 in for the x and plug 3 in for the y, or f of x, and see what you get for a. So we're going to plug a 3 in here, a times, and I plug a 1 in there, so 1 plus 1, 1 minus 2, and 1 minus 4. Let's work it all out. So in the first set of parentheses, I get a 2, and then a negative 1, and then a negative 3. Multiplying this out, negative 3 times negative 1 is positive 3, times 2 is 6. 6a equals 3. Divide by your 6, so your a must be equal to half. Okay, so rewrite the function then. F of x is equal to a half times x plus 1 times x minus 2 times x minus 4. Still not too terrible. And I got it to go through a particular point. Okay, so here was your second one there. So x equals 4, subtract it over, or just change the sign. So your factor is x minus 4. For the second one, 1 plus the square root of 5, it's irrational, so I should also expect 1 minus the square root of 5. If I set that equal to x, subtract over the 1, then square both sides. When I square both sides, left-hand side becomes x squared minus 2x minus 5. Square to square root, they just cancel it out, so I have 5. Subtract that 5 over, and then I have my quadratic second factor. And then FOIL those two things out. Whenever I FOIL those two things out, expand it out, get a final equation of f of x equals x cubed minus 6x squared plus 4x plus 16. Okay, here was the last one. Last one, first factor, not a problem. It becomes x minus 2. Next one, x equals plus or minus 2i, because it's imaginary. It should come in a pair. Square both sides, and so you get x squared equals 4i squared. I squared, same thing as negative 1, so that turns into negative 4. Add that thing over, so your middle quadratic term is x squared plus 4. And then for the last one, it's irrational. It's irrational, must come in pairs, so 4 plus or minus the square root of 6. Subtract the 4 over, square both sides, and then get that 6, subtract that 6 back over to the other side. There's your next quadratic factor. And I just lined them all up. You can expand it if you wanted to, if you had an extra 25 minutes on your hands. But that's good enough for us. All right, that's it.